Okay, so we are going to be working on um, this idea of types of numbers. So we've talked about fractions, we've talked about decimals, we've talked about squares, we've talked about cubes. So all of these numbers that we've been talking about are these things called rational. So we're going to talk about rational numbers and irrational numbers today. So, rational and irrational numbers today, and we are on page 80. Let me get my notebook. My iPad's a little too close to write or to flip the pages. All right, so page 80, rational and irrational numbers. All right, so almost every number you work with on a regular basis in math class this year has been what's called a rational number. And so let's define, a rational number. So a rational number is any number that can be written as a fraction. And that's why we did all of that work of converting, right? So it's any number that can be written as a fraction. So like types of numbers, like what types of numbers could be rational numbers? Well, fractions are rational numbers because can a fraction be written as a fraction? Yeah, it's already a fraction, right? So let's give some examples. Let's change colors. Let's go examples. Well, a fraction. 1/2, 9/4, 3 and 2/5. Let's make that one negative even, right? All of those are rational numbers because they can be written as a fraction because they're already a fraction. We've done some work with decimals. Decimals, can they be written as fractions? Yeah, a decimal can be written a fraction because you just read it correctly, right? So like 0.1 is really 1/10. Negative 4.07 is really negative 4 7/100, right? Even repeating decimals, so like 0.3 repeating is 3/9, which is 1/3, right? Because it would be 3/10, but instead of 10, we'd subtract 1 from the decimal or from the denominator. So it would be 3/9, right? So if it is a decimal and it repeats, if I can take a repeating decimal, I can change it into a fraction. So decimals. So it either terminates or repeats a decimal. So a fraction, a decimal, right? Yes. So if it terminates, if it stops, it works. Or if it repeats, it works. I have these rules, right? Remember my rules over here, terminating decimals and repeating decimals. So fractions can become a fraction because they're already a fraction. Decimals can become fractions because we read them correctly, right? And then we write that fraction down. So like a whole number, for example, 4 can become a fraction because it's just 4/1, right? Positives and negative numbers, those are called integers. So like negative 3 becomes negative 3 over 1. So fractions can become a fraction. Decimals, if it's terminating or repeating, it can become a fraction. If it's a whole number or an integer, it becomes a fraction. 0 works because 0 over anything equals 0. So, I mean, like, basically everything that we encounter is this idea of a rational number. There is one group, though, that does not work, that is not a rational number. And that non-rational number, so the opposite of that, is what's called irrational. And an irrational number is a number that cannot be written as a fraction. And so we talk about this idea of irrational numbers, and it's really hard to like come up with things because it's can't be a fraction, it can't be a whole number or an integer, it can't be 0, and it can't be a terminating or repeating decimal. So there's really only one category that doesn't fit into these examples up here, right? These are the examples of rational. So what would be an example of an irrational number? Well, an example of an irrational number is, we'll change colors. It's a decimal that does not terminate or repeat. Can you think of a number that you know of really well? We use it a lot in geometry, that a number, a decimal value, that never terminates, it never ends, and it never repeats. Did you think of one? There's a really famous one. Example. Pi. Pi never ends and never repeats. It goes on and on forever and ever and ever. Never ends, never repeats. That's why we use this symbol for the number, because there's no way to know what the value is, because it's this never ending, never repeating, goes on forever type of number. So like that's the biggest one, right? Like pi is irrational. There is no known ending value. The other one that we need to know is the square root of a non-perfect square. For example, the square root of 11. You can't do the square root of 11. Remember when we did our square root numbers? These are the only square roots and continuing that work. So like 11's not in here. So the square root of 11 is this never ending, never repeating number. I'll show you, right? So I've got my calculator. And if I do 11 and then the square root of it right here, it's this decimal that does not repeat, and it goes on forever and ever and ever, right? So it is a value, a number that doesn't work. So like the square root of a non-perfect number, for example, the square root of 11, or the square root of 20, or the square root of 50, there are a lot of them. Right? There are a lot of numbers that don't work. So you're going to use this knowledge, right, to help you figure out, are numbers either rational or are they irrational? There are a lot more rational numbers out there than there are irrational numbers. Irrational numbers have to come with either pi, some version of pi, so like maybe it's do, maybe it's like 3 pi, right? That would be irrational, right? That's not gonna have a solution. Or the square root of, it does have a solution. It's not gonna have a solution you can put into a fraction. Or the square root of a non-perfect number. So like, I mean, the square root of 8 doesn't work. The square root of 15 doesn't work. If I wanted to go the cube root of 40, right? So I would look at my cube roots over here, and 40 is not in my list. So it's irrational. It's this never-ending, never-repeating number. If it repeats, we can make it into a fraction, so it's a rational number. But since these numbers never repeat and they never end, they are called irrational numbers.